Okay, now that I'm basically finished with the 1.5 ton York unit there, it's now time to move on to the final touches on the new 3-ton Goodman unit. I went ahead and re-insulated the suction line. This looked like the original installation from 1985 when the house was built, so I put all new Armorflex on here. So that's all taken care of. And I went ahead and raised the whole unit up by about 3/4 of an inch with the, you can't see them, with the rubber anti-vibration pads. So this is not going to get nearly as, it would be less likely to get dirty down in this area here where the coils are. Just trying to protect it and get more life out of it. And this thing ran really good last night and darn near froze me out of the bedroom. So this thing's in good shape for now. This Goodman unit is a TXV controlled unit. It's an R410A system. Just as before, I've got the refrigerant sitting on a refrigeration scale. And we're upside down because it's actually a mixture of 2 refrigerants, so we got to go in as a liquid. And because of that, I've got the imperial flow restrictor on the output, because you generally don't want to go in as a liquid on the low side of the system. You can damage the compressor, you can slug the compressor, but the restrictor right there is going to ensure that no matter what I do in the gauges, even if I go wide open, I will not slug the compressor. It's just a way to error-proof the process. This is a unit I installed myself. It comes with enough charge for about 15 feet of line set. I've got about 57 to 58 feet of line set, so I've got to adjust the charge and basically top it off. I've had it running for about 20 minutes now. And I like instrumentation, I like visibility into my system, so when I brazed all these connections, I went ahead and added a sight glass and moisture indicator here. You generally don't find these on residential systems, you find it more on commercial systems, but it's just one more piece of information that a technician can gain when coming up on a system that's having problems. So if that yellow dot is green, then the system is dry. If it's yellow, then you know you have non-condensables in there. You got moisture in there somehow, probably due to a leak. So now, what we're looking for, this is a TXV controlled system, so unlike the York unit we just looked at, the superheat is basically set at the factory, and the setting is between 7 to 9. This TXV tends to overshoot and undershoot just a little bit. You'll see it go to around 10 and then maybe back down to 4, but the thing to look for is to realize that it spends most of its time in the 7 to 9 range. It's going to fluctuate a little bit, but it shouldn't be way out of whack. This unit is running, it's a 2-stage unit, the 2-stage compressor. It's currently running in the high stage, and for high stage cooling, the subcool should be between 7 to 9. So it's kind of easy. We're looking for a subcool between 7 to 9, and we're looking for a superheat between 7 to 9. The superheat is not going to change very much when I add charge, or at least it shouldn't, unless it's grossly undercharged. If I don't have liquid going to the expansion device, we'll have problems. So I shouldn't really have to pay too much attention to this number, except to realize whether it's accurate or not. This is a TXV, same TXV that's in this unit here. It's a thermostatic expansion valve, and basically what it does is, as this sensing bulb that sits on the suction line, as the temperature goes up and down, it'll actually increase pressure on a spring inside of here to modulate this valve, more open or more closed. And on this particular model, you can actually take off this end cap here, and you can adjust the superheat just with a little 3/16 wrench, it looks like. So that would be the proper remedy If the superheat on this system is way out of hand and your charge is correct, then you would look at adjusting the TXV one turn clockwise, increase the superheat by 4 degrees on that model. But I don't think we're going to have to mess with the TXV right now. Looks like for the most part we're just going to have to worry about subcooling and get that number to between 7 to 9 degrees. So we'll go ahead and fire up our scale. And we'll go ahead and zero it out. And now we'll be able to see, just like yesterday, if I can ever get this to stabilize, just how much refrigerant we actually add in. So we're going to charge on the low side, and with this particular manifold we can go ahead and just open the low side all the way. Nothing's happening right now. We'll just backseat that a little bit, and we can control everything with the refrigeration valve right here. We're pretty close on our subcooling. So unlike the York unit, we should not have to add that much more charge. So we'll go ahead and crack the valve open. And I'll just add maybe an ounce, just 1 ounce at a time. A little bit at a time, just like before on the York unit. This whole process takes time. So we want to just add a little bit at a time, shut it down, and let everything stabilize. And already, just after, looks like it jumped up to 2 ounces. We're between 7 to 9 on our subcooling already. So I'll let this run and see if that's actually a good number or if I have to add more charge. I think we are real close. I'm going to basically stop here with the charging process. The magic number was just 5.3 ounces. And it's interesting to note that unlike charging as a gas with the R22 systems, when going in as a liquid, you got to be really careful and just tweak that valve ever so slightly, because you'll end up dumping a lot of liquid in here really fast. You'll see that the numbers on the scale go up really fast and end up overcharging the system, which is bad news. So I ended up actually going in basically a half an ounce at a time to reach 5.2 ounces. Took me about maybe 45 minutes of sitting here and looking at all the information on the manifold set. The superheat and subcooled numbers are going to dance around a little bit just as a function of normal operation with airflow in the house, temperature changes in the house as the temperature comes on down. But they should be within the envelope of 7 to 9 degrees in this particular case with the Goodman unit here. So our vapor saturation is 48.4, so we're not going to freeze the coil. And we're condensing at 90 degrees, which is a little bit low for the traditional types of systems. 7 degree, it's about 80 degrees out here, so basically a 10 degree difference with the condenser coil. Usually that should be higher, but the main thing to look out for on these units, the TXV controlled units, is the subcooling, charge by subcooling. It's good to know the superheat just as a point of reference, just to make sure that the indoor TXV is operating like it should. You don't have any airflow problems or anything like that, but the subcooling is what you want to go by when you're charging. Our low side and high side pressures look good. That number actually looks a little bit low for an 80 degree day, but maybe not. I'm still getting used to these high efficiency systems. They tend to operate a little bit differently than the 13 SEER units. But I think I'm basically properly charged here. Subcooling is staying within 7 to 9, and superheat is staying between 7 to 9. Just watch these gauges for a little while. You can see how they just kind of dance around as the TXV modulates, opens and closes. Superheat's going down now, so that TXV is starting to feed more refrigerant into the indoor coil. And then in a few minutes it'll swing the other way and start shutting off refrigerant to the coil, and the superheat will rise. Our sight glass looks good. We've got solid liquid going in there. You can't adjust your charge by the sight glass. But it is a good indicator that you definitely have a solid liquid in there, which is what you want. So I'm going to go ahead and call this thing properly charged, and I'm glad it didn't take but just a few ounces. And I'm going to enjoy some nice cool air conditioning here in a few days before the really bad dog days of summer arrive.